Recent enterprise surveys show that 88% of organizations report using artificial intelligence in at least one business function. Executive teams are actively deploying models across their operations to drive efficiency. But this chart reveals the operational reality. We see the 88% adoption rate contrasted directly with an 89% failure to deliver rate. Nearly 9 out of 10 operations leaders state their technology investments have not fully delivered the expected results. Over the last decade, organizations digitized forms, deployed mobile applications, and added dashboards. The working assumption was that layering more software onto a workforce would automatically yield operational intelligence. Speed without structure creates liability. Dropping an AI agent on top of disconnected workflows, outdated technologies, and weak master data does not fix a broken process. It accelerates error propagation. The organizations that capture value in the next decade will stop buying isolated apps. They will focus on turning execution at the edge into a governed, observable operating system, building an AI-consumable enterprise. This model of system truth represents the pristine record of what your ERP or WMS calculates happened. Compare that to operational truth, the fragmented reality on the warehouse floor or customer site. When delayed, the system's understanding lags behind physical facts. We call this drift. The symptoms of this drift are immediate. Inventory counts mismatch, routes deviate without record, proof of execution gaps widen. By the time the systems reconcile, the window to correct the issue has closed. An AI model cannot optimize a physical operation if its calculations are based on a delayed, inaccurate version of reality. Current operations research indicates that 87% of supply chain and operations leaders point to poor data quality as the primary bottleneck holding back their digital initiatives. The standard corporate response is to build more dashboards to increase visibility, but visibility only provides a binary status. It tells you whether a truck arrived or a task was checked off. Observability requires far more strict architecture. It demands a system capable of reconstructing workflows, diagnosing exactly why an exception occurred, and measuring whether the resolution loop functioned as intended. Without observability, exceptions sit unresolved. A delayed shipment might trigger a dashboard alert, but without the contextual data to route the issue to a specific human owner with a service level agreement, physical assets sit idle. Algorithms cannot operate safely in illegible environments. Observability is the mechanism that translates the physical world into a machine-readable format. The architecture starts with ERP and core systems at the base. Above sits the execution layer, capturing physical work at the edge. Next, the event and telemetry layer translates those raw inputs into a structured history of operational events. This uniform, structured telemetry is the strict prerequisite for advanced computation. Without it, you are feeding unstructured noise into complex decision models. Enterprise architects have to build and stabilize these bottom data layers before they can introduce any automated decision-making. Next, we add the orchestration layer. This control plane actively routes work and exceptions based on telemetry. Only now does the AI layer sit on top, receiving governed data to predict failures and recommend interventions. This stack enables operational digital twins. Rather than static 3D visualizations, these are live structured models of work, assets, and constraints used for daily planning and stress testing. To protect the entire system, 2 vertical pillars flank the stack: human governance and security and resilience. They ensure system reliability, control latency, and maintain strict authority over automated actions. This architecture enforces the core rule of the intelligent age. Governance must strictly precede automation to ensure artificial intelligence acts safely in the physical world. In current operations surveys, only 4% of respondents meet the profile of high-performing orchestrators. The vast majority remain stuck in isolated digital pilot programs. On this maturity curve, we cross a critical threshold into the observable stage. Here, telemetry and exception histories let leaders govern in real time. Past this, operations enter the semi-autonomous zone. Systems dynamically reprioritize and route exceptions using AI, while maintaining required human oversight. External regulation is compressing the timeline to reach this maturity. Mandates like the FDA's traceability rules, alongside the European Union's AI regime, are making event-level data and responsible AI controls a compliance baseline. Structuring operational execution data is no longer an internal IT initiative. It is the dividing line separating future market leaders from laggards. We have to address a pervasive executive misconception. Autonomous operations do not equal humanless operations. In a physical enterprise, autonomy requires supervised automation. It depends on strict policy controls, safety boundaries, and explicit mechanisms for human override. This reality shifts frontline roles. Supervisors become coaches who manage with data. Escalation managers step in when AI confidence drops or customer commitments are at risk. Operational success requires redesigning labor, decision rights, and operating cadences around machine-assisted execution, rather than seeking pure labor substitution. The definitive advantage in the coming decade belongs to leaders who focus on making their physical operations fully legible, tightly governed, and machine